Hey guys, welcome to a new video. In this video, I'm going to be solving a problem which you might find quite interesting. So we have a picture of a cyclist here, and as the cyclist is actually moving from the left hand side to right hand side, what's going to happen is he's going to experience a drag force. Alright, so the cyclist, when he pedals, he has to overcome this drag force, which is basically wind resistance. So what we are going to do is we are going to write a program that actually calculates the drag force, and we are going to be running some parametric studies. So for those of you who are not familiar, the drag force on any given object is half times the density of the fluid that the object is resisting times the frontal area. Okay, we'll explain what the frontal area is. And then there is velocity square, which is the velocity with which the bike or the cyclist traveling forward, and then there is actually a constant in front of it, which is called as the drag coefficient. Alright, so whenever you are given an equation, at a bare minimum, work out the units. So the drag force needs to have a unit of Newton, because force, we know that the unit for force is Newton, and Newton is nothing but mass times acceleration. So the left hand side unit is going to be kg, meter per second square. So kg is the unit for mass and meter per second square is the unit for acceleration. So let us work out the unit on the right hand side. So for density, the unit is kg per meter cube, and for area the unit is meter square, and for velocity the unit is meter per second, and since there is an exponent of 2, you will get meter square per second square. If you basically do the math, this is going to be kg meter per 4 by meter cube by second square. This is going to cancel this guy, and at the end you will have kg meter per second. Note that in this process we did not take into account CD. Alright, but even without including the CD, the left hand side and right hand side unit matches, and that is why your drag coefficient is unitless. Okay, and this is also called as a non-dimensional quantity. Right, because non-dimensional means it does not have any dimensions, which says that there are no units for that particular variable. Okay, so here what we are interested in learning is, so let us say that there is a cyclist traveling at a particular velocity. What's going to happen to the drag force? That's what we are interested in, and we are going to be writing programs for it. As I said in the start of this video, we are interested in this area, and this area is basically your frontal area. So this is the area that the flow is actually facing. So in this particular case, it's going to be the area of this complex shape. So let me use a different color. So if I'm able to calculate this area, we're basically projecting the man's shadow. And then if I'm able to calculate this area, anything that is black, I need to take into account. Alright, so this is called as your frontal area A. Now estimating this is very hard, but you need to understand that as you are changing positions when you're pedaling, you're changing your area, and because of this area change, the drag force that you're encountering is going to change. And that is why if you watch some bicycle competitions or cycle competitions, you will see that people are changing their positions to make sure that they experience the least amount of drag as possible. Alright, so that being said, now let's get to the programming part. Alright guys, to get started, I'm going to open a new script file, and I'm going to be starting with the lines clear all, close all, and CLC. Okay, so whenever you start a new program, it is a good practice to include some comments. So I'm just going to include that in the first line actually. Let us say that this is a program to calculate the drag force on a bicycle. Alright, so now let's declare some input variables. So what are our inputs? So to start with, we'll define the drag coefficient, and we can say that is 0.8. Include as many comments as you want, especially in the initial days when you're just now starting out with programming. Alright, and the next thing is frontal area. I'm just going to assume it's 0.1. And you can just keep track of the units as well. I'm going to assume that this is all in meter squares. and I'm going to assume that the area is in meter square. The next thing that we need to declare is the density, density, and I'm just going to call it as rho, and we can say that rho is 1.2 kg per meter cube. What else do we need? We finally need the velocity, so we can just call that as v. Maybe first start with a comment, and v equal to 1 meter per second, right? So your drag force, you can just call it as drag underscore force, is rho times a times v times cd times a factor of half, which is 0.5. So let me save this program, and I'm just going to call it as drag force calculation. And you can see that I'm getting an error because I'm using the variable a here, so it needs to be uppercase A. So now you can see that the calculation is done and my drag force has been calculated. So now let us say that we want to calculate the drag force for multiple values for v. Then what I can do is I can just say v is 1, 2, 3, 4, and 5. So v is an array. In Matlab it's a matrix. So in this case it's a row vector. It has 1 row and 5 columns. Okay. And for each value for velocity, we are going to be calculating the drag force. And all I need to do is just use the element wise operator. And one thing I just realized is it should be v square. So, there needs to be two v's, right? Because drag force is half rho a v square times cd. I can put it like this, or I can just say v cap 2. Now remember, v is a matrix, so we need to use the element wise operator. So it should be v dot cap 2. And if I execute it, you can see that drag force is also an array. So then I can immediately create a plot of velocity versus drag force. And if I execute the code, I get my plot. You can see that the variation is quadratic. Now what else can I do here? So instead of typing in 1, 2, 3, 4, 5, I can just say, 1:5. So 1:5 is the range operator. It automatically generates the array. So this is a very convenient feature to use. So what I can do is I can just type in 1:5. All right. And since I'm using the range operator, I can use 1:50 as well. That's it. So which means I'm using 50 values for v. And you can see that the curve is much more smoother, and you can see its parabolic variation. Now you can see that a lot of values are getting printed on the screen. I don't like this, so I can just use a semicolon at the end of my velocity and drag force statements. And if I execute the program now, no values are getting printed. The plot appears, and let's just add some x label, x-axis, and y label, y-axis. All right, so that looks good. I can also turn on the grid and do something like this. So now this is great. I mean, I can, do the same thing for changing the area or for changing the density. But with respect to drag force, the velocity is the most important variable because, your drag force, okay, my y label can actually be drag force, and x label can actually be velocity, so that the plot looks more meaningful. So as you change the velocity, then your drag force is increasing proportional to velocity squared. So if you increase the velocity 2 times, your drag force is increasing 4 times. So with respect to aerodynamics, here is a major problem. So when you're designing cars, if you're able to travel like 2 times faster, the drag force is 4 times more, which means your fuel economy is going to, drop proportional to your drag force, which is bad. So that is why, supersonic flights are really small, because that reduces the frontal area and also the drag coefficient, so that the drag force can be kept as small as possible. Okay, so write this program, and there's also a couple of challenges in the leaderboard interface for you to work on. We'll be posting the next video shortly. All right, good luck.